The paper titled, M-MRE, Extending the Mutual Reinforcement Effect to Multimodal Information Extraction, is authored by Chengguang Gan from Yokohama National University in Japan, Sunbo and Li from the College of Science at Wuhan University of Science and Technology in China, Zhixi Kai from Monash University in Australia, Yanbin Wei from both Southern University of Science and Technology in China and the Hong Kong University of Science and Technology, Lei Zheng from Shanghai Jiaotong University in China, Yunhao Liang from the University of Chinese Academy of Sciences in China, Shiwen Ni from the Shenzhen Institute of Advanced Technology in China, and Tatsunori Mori from Yokohama National University in Japan. At its core, this research explores an emerging concept called the mutual reinforcement effect, or MRE, which sits at the intersection of information extraction and model interpretability. MRE is about how different tasks in machine learning can mutually enhance each other by sharing insights, particularly when these tasks operate at different levels of detail. In simpler terms, it's like having two or more processes that help each other improve by working together. So far, MRE has been studied mainly in the realm of text-based information extraction, where it boosts the performance of both broad, coarse-grained tasks and more precise, fine-grained ones through joint modeling. In this work, the authors are taking MRE a step further by applying it to multimodal information extraction, which involves not just text, but also images and other visual data. This is a new frontier because while MRE has been validated in purely textual scenarios, its potential in visual or combined text-image environments hasn't been explored until now. To do this, they introduce a novel task called Multimodal Mutual Reinforcement Effect, or M-MRE, and they've even created a dedicated dataset to support it. Let's break down what multimodal information extraction entails. Traditionally, information extraction in natural language processing focuses on pulling out specific pieces of data from unstructured text and organizing them into categories. For example, tasks like named entity recognition identify and classify items such as names of people, organizations, or locations from text. Other related tasks include relation extraction, which figures out how entities are connected, and event extraction, which spots events or actions described in the text. With the rise of advanced multimodal models in recent years, researchers are now incorporating visual information alongside text. This means that instead of relying solely on words, the system also uses images to make more accurate classifications. In multimodal information extraction, the model has to match textual entities to relevant parts of an image. A key example discussed in the paper is multimodal named entity recognition, or M-MRE. Imagine you're looking at a news headline paired with an image, like a photo from a sports event. In M-MRE, the model performs three interconnected subtasks. First, it conducts named entity recognition on the text, identifying and labeling entities such as organizations or people. For instance, in a headline like, NBA, Spurs rout Thunder, it would extract Spurs and Thunder as organizations. The second subtask involves detecting and segmenting objects in the image. This means the model scans the image, identifies distinct elements, and breaks them into separate patches. In the paper's example, if the image shows a basketball game with several players, the model might detect and segment individual figures, labeling them as patches A, B, and C. The third and most integrative subtask is matching these textual entities to the corresponding image patches. So, going back to the example, the model would link the entity, Spurs, to the relevant player or team visual in the image patch. This creates a more comprehensive understanding by combining textual and visual data, making the extraction process richer and more accurate. The authors point out that this M-MRE task is the central focus of their paper, as it exemplifies how multimodal information extraction goes beyond text-only methods. By incorporating visual context, the model can resolve ambiguities that text alone might not handle well, like confirming that a mentioned organization is indeed depicted in the image. To tackle the challenges of M-MRE, the researchers propose a tool called the Prompt Format Adapter, or PFA. This is designed to be fully compatible with various large vision language models, which are advanced AI systems that can process both images and text. The PFA acts as a bridge, adapting prompts, those instructional inputs that guide the model, so that they work seamlessly across different tasks in the multimodal setting. This adaptability is crucial because it allows the model to handle the mutual reinforcement between tasks without needing custom tweaks for each system. In their experiments, the team demonstrates that the mutual reinforcement effect can indeed be observed in this multimodal context. They tested M-MRE on their newly constructed dataset, which likely includes paired text-image samples to simulate real-world scenarios. The results show mutual gains across the three interrelated tasks: text-based entity recognition, image segmentation, and entity image matching. This confirms that MRE isn't limited to text. It generalizes to multimodal environments, providing a stronger, more versatile approach to information extraction. The paper also touches on broader implications. By extending MRE to visuals, it opens up possibilities for applications in areas like social media analysis, where posts often combine images and captions, or in automated news processing, where visual verification can enhance accuracy. The authors reference various prior works in information extraction and multimodal modeling to ground their contributions, citing studies on named entity recognition, relation extraction, event extraction, and the evolution of multimodal models. One interesting aspect is how this work aligns with current trends in AI, such as the use of large vision language models like those from Archive or other cutting-edge research. The paper's Archive identifier is 2504.17353v1, dated April 24, 2025, indicating it's a recent preprint. They emphasize that M-MRE provides evidence of generalizability, meaning the principles of mutual reinforcement can be applied across domains, potentially leading to more efficient and interpretable AI systems. In terms of technical details, the authors discuss how joint modeling in MRE helps fine-grained tasks, like entity matching, by drawing from coarser tasks, such as overall image recognition, and vice versa. This bidirectional enhancement is what makes MRE powerful, as it creates a feedback loop that improves overall performance. Finally, the paper includes CCS concepts and keywords, though they appear to be placeholders in the provided text, suggesting areas like information systems, artificial intelligence, and multimodal learning. Overall, this research advances the field by bridging textual and visual information extraction, paving the way for more sophisticated AI applications that understand the world in a more human-like manner.